Welcome back to the channel, everyone. In today's video, we're going to learn how to upload files using RestTemplate and WebClient in a Spring Boot application. If you've ever wanted to upload images, PDFs, or any other kind of file to a server, this video is for you. I'll walk you through the process step by step. Don't worry, I'll keep it simple and easy to follow, especially for beginners. Last time, we set up a REST API to upload files to a server and tested it using Postman. But what if you need to upload a file from one service to another? Well, today, that's exactly what we're diving into. We're going to learn how to use RestTemplate and WebClient to upload files between services. It's super useful when you're working with microservices or different apps that need to communicate with each other. In this video, I'll walk you through the process step by step, and by the end, you'll know how to upload files from one service to another like a pro. Let's jump into it. Alright, now if you're looking at my screen, you'll notice I've selected the RestTemplate code here. This is the exact code we wrote earlier for sending the request body using RestTemplate, and guess what? We don't need to add anything new for uploading files. We can use the same code here. Now, let's look at WebClient. You can see it on my screen as well. This is the same code we wrote in our WebClient video, so we don't need to add any extra lines of code for file upload here either. Everything we need is already in place. So as you can see, whether you're using RestTemplate or WebClient, uploading files is as simple as this. We're just reusing the logic from earlier and making the upload process super smooth. Now, let's move on. Create a file upload service inside our REST client service. Annotate it with its service, which tells Spring to manage this as a Spring Bean. Now, inside this service class, we need to inject the REST client bean. The best way to do this is through constructor injection, so let's define that. Next, we need to inject the base URL as well. We've already defined the base URL in the employee service class, so it makes sense to reuse that property. Copy it from there and inject it into our file upload service class. This way, we don't need to define the base URL again, we'll just use the existing property. Now, let's create a new method called uploadFile in our file upload service class. First, define the resource URL, which in this case is file/upload, where the file will be sent. This is the endpoint for our file upload operation. Now, let's move on to setting the headers for our request. Since we're uploading a file, the content type header needs to be set to multipart_form_data. This tells the server that we're sending a file as part of our request. Additionally, we want to specify that we're expecting a plain text response, so we'll set the accept header to text_plain. Let's create an HTTP headers object to hold these headers. Add content type header and then set the accept header as well. This step is crucial to make sure the server understands what kind of data we're sending and what we expect in return. Now, let's move on to the body of the request. Since we're sending form data, which could include both text and file resources, we'll need to use a MultiValueMap. This allows us to handle multiple values for a single key, which is important when we have both text and files to send. Now, I'm going to send a file that's located in my Downloads folder. Alright, let's start by creating the file path. Since I'm going to upload a file from my Downloads folder, I'll create the path to that folder first. This is where our file is located. So, as you can see, I have my springboot.png file right here in the Downloads folder, and today, I'm going to upload this file to the server. You can try uploading your own file by simply changing the file path to the location where your file is stored. Let me know if you run into any issues. I'm happy to help. Alright, now let's create a file object for the file we want to upload. Here, I'm passing the file path we defined earlier to create the file object. Alright, now we're creating a file system resource object. Let me quickly explain what it does. So, the file system resource is a Spring utility class that acts as a bridge between your file and the API request. It essentially wraps your file object and makes it easier to handle when sending it over HTTP. For example, it knows how to read the file's content, determine its size, and even manage its streaming during the request. Think of it as a helper that ensures the file you upload is correctly packaged for the API to process. And here's the best part, you don't have to manually read the file or handle its byte stream. File System Resource takes care of all of that for you. It's like having an assistant who knows exactly what the server needs. Alright, now let's create an object of File System Resource. We'll pass our file object to it. The file system resource will internally manage all the necessary details about the file, like reading the file's content, determining the file's size, streaming the file during the upload process. It's like a smart wrapper that ensures the file upload process is smooth and efficient. Now, let's create an object of MultiValueMap. This MultiValueMap is perfect for handling form data. Think of it like a multi-slot container where you can add multiple key value pairs. Remember, if you want to send additional form data along with a file, like a user ID or any extra metadata, you can just add more key value pairs to this map. Alright, now we need to add our file resource to this MultiValueMap because that's what our API is expecting. The key should match the parameter name in the API, here it's file. And the value will be the file system resource object that we created earlier. Alright, now comes the exciting part, actually sending our file to the server. We'll do this using the execute method from our custom REST-Client class. Remember, I walked you through this earlier in the video. Base URL is where our server lives. Resource URL points to the exact endpoint for uploading. String.class tells the client, hey, I'm expecting a plain text response back. Those null values? They're placeholders because we don't have any query parameters this time. Headers are the same ones we created earlier. HTTP method.post specifies that we're sending data to the server. Those null values? They're placeholders because we don't have any path variables. And finally, body is where the magic happens. It contains our form data, including the file. Now that we've sent our file, let's take a moment to check the response from the server. We'll print out the status and the response body to make sure everything is working smoothly. Now, let's open our REST Service Application class. Comment out the old code. Get the file upload service bean. And call the upload file method to initiate the file upload process. Alright, everything is set up. Now, let's restart the employee service. Let's head over to our demo folder and clean it up. Since our REST API will be writing files to this folder, we want to make sure it's ready for the new files we upload. Now, let's run the REST client. As the log shows, the response is successful, indicating that the file has been successfully uploaded to the server. Now, let's switch to the folder where we expect the file to be uploaded. Here is my demo folder, and as you can see, the file is now there, confirming that the upload was successful. Just like we discussed, the file that we uploaded through the REST client has been written successfully into this folder. This is exactly what we wanted to achieve. It's always great to see everything come together after testing. Now, let's move on and do the same thing, but this time, we'll use WebClient instead of RestTemplate. Now, let's inject the REST web client into our service class so that we can use it for our file upload functionality. As you can see, we already have the REST-client.execute method being used to send the file upload request. Now that we've injected REST web client, we just need to replace the REST-client.execute call with REST web client.execute. Before we send the file, we need to make sure that the folder where the file will be written is clean. So, I'll go ahead and clear out the demo folder. Now, let's go ahead and run the REST client service. As you can see in the logs, we got a success message. Now, let's check the folder to confirm if the file was successfully written. Here's the demo folder, and as you can see, the file we uploaded is here. Now, in the current setup, we've uploaded a file from the local system. But what if we want to upload the file from an input stream or byte array instead? In some cases, you might not have a physical file ready to upload, but rather have an input stream or byte array. In such cases, we need to handle this differently. Uploading files through input streams or byte arrays is useful when you're dealing with data that's not stored as a file on your machine, but is coming from another source, like a remote server or an application. First, let's copy the upload file method that we wrote earlier for uploading files from the local system. Now, let's rename it to upload file input stream. Now, instead of reading the file from a local path using the file object, we will directly read the file as bytes and store them in a byte array. No longer need the file object since we are not using a local file path to upload. Let's use files.readAllBytes to read the file directly into a byte array. This will allow us to handle file content as a stream of bytes. First, we'll create an input stream object to read the file's data. Previously, we used file system resource to wrap the file object. Since we're no longer dealing with a file object, we can remove this part of the code. Let's now create an object of input stream resource and pass the input stream. So, what is input stream resource? It's a Spring class that lets us wrap our input stream into a resource that can be used in HTTP requests. It's perfect for situations where we want to send data in a stream rather than a static file. If you have a byte array and want to send it as part of the request, you can use byte array resource. This is a simpler way to send byte data directly over HTTP. Using byte array resource, we don't need to wrap the byte data in an input stream. We can directly use the byte array, which makes the code cleaner and more straightforward. When you're sending a file over HTTP, the server expects a file name to be included in the request. Since input stream resource and byte array resource don't inherently know the file name, we must override the getFileName method to provide it. By default, input stream resource doesn't know the size of the content because it's dealing with an input stream. The content length method tells the server the size of the file being uploaded, which is essential for efficient file handling. When you're sending data using input stream resource, you need to explicitly provide the content length, because the input stream doesn't directly offer this information. So, let's override the method. So, let's take the input stream resource object we created earlier and add it to a MultiValueMap.
Now, let's clean our folder.
Now, let's go ahead and run the REST client service to trigger the file upload process. See in the logs that the status shows success. This indicates that the file upload was successful. Now, let's move over to the demo folder to verify if the file has been uploaded successfully. As you can see, the file is now successfully uploaded to the folder. Everything worked as expected. Alright, let's wrap up what we've learned today. In this video, we successfully implemented file upload using RestTemplate and WebClient. We went through the process of sending a file to the server and verified that it was uploaded successfully. In the next video, we'll learn how to download files using RestTemplate or WebClient. Stay tuned for that. Thank you for watching. Don't forget to subscribe to the channel and hit the notification bell so you don't miss any updates. See you in the next one.